Okay, let's go to Redis Cloud Console. Here we need to create a new database. Here select everything the same as I have. It's all free and you don't need to pay anything. Let's call our database Redis car. Select here 30 megabytes and click create database. You need to wait a little and we will see all the data we need to connect. Click here connect and let's access this data later, but for now let's create our next application. Now we need to create our next application. Let's call it Redis car app. Okay, Redis car app. You need to wait a little. Okay. Here just choose everything that is recommended to you. Okay, yes, no, yes, yes, and no. Now let's wait, and after installation open our application in VS Code. Let's wait. Okay, let's wait. After successful installation, let's go to our project. CD Redis car app. And open it in VS Code. Okay. Now let's create all the files and folders that we need. First, let me show you how to create our Redis URL in .env.local. Okay, Redis URL. Just replace here with data that you were given, and this will be your Redis URL. Okay, default password, host, port. Now I will show you how I will create my Redis URL and you will understand everything. Let's copy password. You just need to go to the Cloud Console and take the data that we need one by one. Oops. Let's copy again. Okay, copy password. Paste. Then we need a host. Let's copy. Okay, paste. And then we need a port. Let's copy and paste. We have done everything and how and now let's create all the other folders and files. Let's start with the lib folder. In it we need to create carform.js, then search form.js, and Redis.js. Now we need the pages folder. So that we don't have a conflict here, delete the page we don't need in the app folder. In pages we need two files. First app.js and second index.js. And in pages we will have let's create a folder API, and in API we will have cars.js, create index.js, and search.js. Okay, search.js. Now we need the styles folder. In styles folder we need to create a globals.css file and paste the code from the repository under the video here. Now we definitely need to install Redis OM. But specifically we need version 0.1.7 because nothing will work for you. Let's see. Okay. Okay, let's copy and paste. Okay. Okay, let's see what we don't need, and it seems like this is all for a start. Let's start with Redis.js. Close all, and we need to import client, entity. We need schema, and we need repository from Redis OM. Okay, next we need to create an instance of client which allows us to interact with Redis. However, at this point the client is not yet connected to Redis. Let's create a connection function. Let's define an async function called connect, First we check if the client is already connected using client that is open. If it's not connected, we establish a connection using client that open with Redis URL. Okay, let's client that open, and we use Redis URL from .env. And we need to open in Redis inside. Okay, I have an error. Okay. Okay. Let's open. Why error? Okay, let's continue with Redis.js. And I will reinstall the application, and then I will show you everything. Okay, let's create a car class that extends entity. Entity is a special class from Redis OM, allowing us to define objects that will be stored in Redis. Right now this class is empty, but it will be used with a schema to define properties. Okay, let's create a schema for the car entity, specifying the properties that each car should have. Each property has a type string. We need car brand. Let's copy and paste and rename. We need car brand. We need car class. We need car cost. We need image, and we need description. Okay, description has text search true, which allows full text searching in Redis. Okay, the third argument data structure JSON tells Redis to store the data in JSON format rather than as a simply key value pair. Okay, next let's define an async function, create car. Which takes data as input. It first calls await connect to make sure we are connected to Redis. Next, let's create a repository. A repository is an abstraction that helps interact with Redis. We create a repository for the car schema, allowing us to easily store and retrieve car data. Okay, schema client. Okay, let's create and save in a car entity. Okay, repository that create entity. Create entity with data creates a new car object based on the schema repository that save car. Saves this object in Redis and returns its ID. Finally, the function returns the ID of the stored car, which we can use later to retrieve it. Let's save all. And let's check if we wrote everything correctly here. After I reinstalled the Redis Insight application, everything works for me now. If you have also already downloaded this application, you can open our database there. Let's open Ethernet data there. Let's now create form for creating cars. Okay, let's move in car form. We define a React functional component called car form. This component will render a form and handle form submission logic. Okay. Handle submit is the function that gets called when the form is submitted. Event print default stops the page from refreshing when the form is submitted. Next, we need to extract in form data. New form data. Okay, and event dot target creates a form data object containing all the form inputs. Object inputs that object that from entries converts form data into a regular JavaScript object. Okay, form entries. Next, we need console log with form data to check the collected data. Next, let's send in data to the backend. We send the form data to the backend using fetch. The body contains the form data converted to JSON. The content type header tells the server we're sending JSON, and data method post ensures we're making a post request. Let's body JSON.stringify form data. Headers with content type. And application JSON. Oops. And we need method post. Okay, next let's handling the server response. Let's const result and await res.json. Parses the server's response into a JavaScript object. We log the response to see if the car was successfully created. Okay, and let copy and paste return. We create an array of form fields: car brand, car class, car cost, image, and description. We use .map to generate label and input elements for each field dynamically. Each input field is styled for a clean UI, and we create a simple submit button. And that's it. Save all, and let's move on to cars.js. We need to import the create car function from our Redis file, redis.js. This function will handle saving car data in Redis. Let's defining the API handler. We define a default export function named handler. This function will be executed whenever a request is sent to this API route. Let's create a new car in Redis. We call create car reg.body, passing the request body containing car data. Since create car data is an async function, we use a way to wait for it to complete. The function returns an ID which we store in the ID variable, and we send in the response. .json with ID. And that's it. Save all. Here now we need to install Bootstrap to work with styles. Let's okay. Let's now fill in app.js in pages. This function defines the main component for our home page. In Next.js, the default export of a page file is treated as a route. Since this file is located in pages/index.js, it represents the home page slash. Okay, structuring the page. The main tag acts as the main content container, the better accessibility and SEO. Create a car adds a hidden for the car creation section. Car form renders the car form component, allowing users to create a car entry. HR adds a horizontal separator for visual clarity. Let's save all and move to Redis.js. Sorry, but instead of writing the code that should be in index.js, we wrote it in app.js. Let's swap them and fill in app.js correctly. Okay. And let's just copy the code and paste it into app.js. This function is the root component that wraps around every pages in our Next.js app. render the specific page the user is visiting, and export my app, and that's it. Now let's move on to creating the create index function. Okay, close. Okay, let's define an async function named create index. The export keyword makes this function available for use in other files. Let's connect into Redis. Before we can interact with Redis, we need to establish a connection. Let's create a repository. A repository is an abstraction that allows us to interact with Redis data in a structured way. We create a repository using a schema, which defines the structure of our data, and the client, which manages the connection to Redis. Let's create an index. This line creates an index in Redis for the given schema. Indexing allows us to perform fast searches and queries. Let's now move on to create index.js. We need to import the create index function from our Redis model. This function is responsible for connecting to Redis and generating an index for our data. Let's define in the API handler function. We define an async API route handler named handler. This function will be called when we make an HTTP request to /API/create index. This function receives two parameters, request and response. Let's execute and create index and send in a response. We use try catch block to handle potential errors. Await create index ensures that our Redis index is created before proceeding. And if successful, we return status with OK. Let's copy error and paste. OK. Then let's create a function for searching. We define an async function named search cars. It takes a query parameter q, which will be used to filter results. We use export so that this function can be imported in other files. Before querying Redis, we need to establish a connection. The connect function ensures that we are connected before running the search. Let's create a repository. The repository acts as an interface between our code and Redis. It allows us to query, filter, and manage data efficiently. Okay, schema and client. And the next, we build in the search query. We start a search on the repository. The query checks for matches in multiple fields. Okay, search. Okay, that where car brand that equal q finds cars where the brand exactly matches with q. That or car class that equal q also check if the class matches to q. Okay, let's copy and paste. The next that or with car cost dot equal q looks for a match in the cost field. And the last we need that or description that matches q, searches for partial matches in the description field equal not, it is matches with q, and we need that return that all retrieves all results that matches the query. Next, let's logging and returning the results with console log. We log the found cars to the console for debugging. Okay, cars found and cars. And finally we return the results so they can be used in other parts of the application. Okay, let's move in Search.js. We import the search cars function from our Redis file. This function handles the logic of querying Redis for matching cars. Okay, from library Redis. Let's define in the API handler. We create an async API route in Next.js. This function will run whenever a request is made to API/search. Let's retrieve the query parameter. We extract the search term q from the request query parameters. This allows users to send requests. And calling the search function, we call search cars q, passing the user's query as input. This function returns an array of matching cars from Redis. And let's send in the response with 200 status and with cars in that JSON. Okay, now we need to create a search form. We import useState, which allows us to manage component state. We'll use it to store search results and update the UI dynamically. Let's create in the component. We define a functional React component called car form. This component will handle user input and fetch data from our API. Let's initialize in state. We create a state variable hits, which will store the search results. The setHits function updates the state whenever new data is received. Next, let's handling user input and fetching data. This function is triggered whenever the user types in the search box. It extracts the input value q. Okay, let's const q, even that target, that value. And the next, we only trigger a search if the user has typed at least 3 characters. This avoids unnecessary API calls for very short queries. And we create query parameters for our API request. This ensures that our API receives the search term correctly. Okay. And next, we send a GET request to our API /search endpoint. The server responds with a JSON object containing the search results. Okay, plus params. Okay, result. Await, raise.json. And let's console log. We log the response in the console, useful for debugging. We update hits with the list of matching cars. And set hits, result, with cars. Okay, let's render in the search input. Let's copy and paste. The input field allows users to enter search queries. The onChange event calls the search function whenever the user types, displaying the search results. And we loop through hits and display each matching car inside a UL. Each car is shown inside an li, which contains a small image of the car brand and class in bold. After we have registered npm run dev, our application has started. Let's now add the first car to our database. Let's find a URL image and copy this URL image and paste in image in create car. Okay, let's car brand Mercedes. Okay, car class maybe sport. Okay, car cost with 333. Okay, and description maybe okay. Let's just random information about this car. Okay, and let's create car. We have added the car, and now let's check the database. Okay, refresh, and here our car is already. That's great. Now go to index.js and let's add the search section here. Okay, maybe I copy and paste. Okay, now let's go and see what we have. Okay, we have an error, and we need to import search form into index.js. I forgot, sorry. Okay, let's import search form. Okay, search form, and now we have everything, and let's try to search by our fields. Okay. Okay. Why for some reason we have an error, and I will now try to solve it. Okay, maybe we don't have index. Yes, sorry, I really forgot to create our index, and without it nothing works. Let's go to API create index, and our index is successfully created. Now we can work with the search, and now we can work with the search, and you can see everything works for us. We can search for a car by price, by name, and what we need. Let's create another car to show you this wall search. Okay, let's description. Okay, price, and let's copy and paste image. Okay, let's create car, and now our new car is also search for by any of its criteria. We can enter any data and it will find. Okay, let's create another one. Let's create another one. I like this. I want to show you how we can find several cars of the same brand. Okay. Okay. Price. Okay, let's change our image for a new car. Okay, let's create, and here look how it works. We'll look at this cool elastic search. We can search by gasoline, by model, by year of manufacturer, by price, and so on. Look. Oops. Okay. Yeah. And I showed you the wall backend and a little design to see how everything works or whether everything works correctly. Now I'm passing you to my partner, and he will show you how to make a cool design for this project. If you want, you can close the video, but I want to recommend it to you and watch to the end, because everything will look very beautiful. I assure you. And I think that's it. Okay guys, we apologize, but there will be no front-end part in this video. We have some problems and can do it now, but if you collect a lot of likes and ask us in the comments to make a front-end part, we will immediately release it, but in the next video. Thank you for watching, and I hope this video helped you and improved your knowledge. See you soon.